Welcome back, my dear student. First, we will see a recap of our previous part. In the previous part, we seen concentration of a solution, and that we seen saturated solution. Saturated solution means no more amount of solute can be dissolved into the solvent. It is called saturated solution. It means that whenever we are trying to add solute into the solvent is not able to dissolve that solute. It will remain undissolved in that medium or in that solvent. Okay, and that is known as saturated solution. And this term, the term unsaturated solution, it is exactly opposite to the saturated solution. Okay, in the unsaturated solution, more solute can be added into the solvent. That solution is known as unsaturated solution. If we are going to try dissolve solute in that solvent, it is able to dissolve that solute into it, and that is called unsaturated solution. After that, we see, and these things at a given temperature, if we are increasing the temperature, ability of the solvent increases. Okay, whenever we are giving heat to that solvent and trying to add again solute in it, and if we are giving heat to the solvent and we are adding solvent into it, and if that solvent is not able to dissolve the solute into it, at that time that solution known as supersaturated solution. Okay, and after that we see concentration of a solution. What is concentration of solution? Concentration of solution is the concentration of solution is a solution, the amount of solute present in a given amount of solvent. Amount of solute present in a given amount of solvent is called as concentration of a solution. And this concentration of a solution we can calculate by various methods, but now we are going to see in this part we see only three ways to calculate the concentration of a solution. First, we see mass by mass percentage of a solution. In this method, we are taking mass of solute divided by mass of solution into 100. Okay, in this way we can calculate concentration of the solution. In the second way, we see mass by volume. Mass by volume. In it, mass of solute divided by volume of solution into 100. Here in this method we see we have to take mass of solute divided by volume of the solution. Okay, and into 100. In this way we can calculate the concentration of the solution. In the third method we see volume by volume percentage of the solution. Okay, in it we see volume of solute divided by volume of solution into 100. Okay, then we can very easily calculate concentration of the solution. Okay, it means percentage of the solution. We see example in it. We see example, very well-known example. A solution contains 40 gram of common salt. Common salt means our sodium chloride. Okay, which is available in our home also. And the weight of that common salt is 40 gram. Okay, salt in 320 gram of water. We are seeing mass by mass percentage of the solution. Okay, here both are given into the mass. Okay, so mass of salt, it means solute. We know what is solute, what is solvent very well. So I am not going to repeat it again and again. Okay, so mass of solute is given 40 gram and mass of the solvent given, that is 320 in this example. Both is mass by mass. By this formula we have to calculate this. Given data we know that salt given 40 gram and the solvent given 320 gram. Now we don't know about the mass of solution. How we can calculate mass of solution? Very easy method. Whenever we are going to combine this mass of solute plus mass of solvent, then it gives what? Mass of solution. So due to this reason, mass of solute plus mass of solvent, 40 gram of mass of solute, that is salt. Okay, and 320 gram mass of water, and if we are going to adding it, it will get 360 gram. Okay, and now we are having formula, that is mass by mass percentage of the solution. Now we are going to use it. Mass of solute, we know that 40 gram. Mass of solute, we know 40 gram, and mass of the solution, now only we calculated, it is 360 gram. So 40 divided by 360 into 100. For the percentage, we need to multiply with the 100, and it will come 11.1 percentage. So in this way we can calculate this mass percentage of mass with the help of mass by mass percentage of a solution. Okay, until now we seen the revision of our previous part. Now we will discuss about our next property. Okay, next point, that is suspension and its property.
Start.
So my dear students, we will start suspension and its property. What is suspension? Suspension is a heterogeneous mixture in which the solute particles do not get dissolved but remain suspended throughout the bulk of the medium. It means that whatever the solute particles are not going to be dissolved into the solvent, okay, they will suspend it. They will suspend in the medium, in the solvent, and it is called suspension. Okay, it is called what? Suspension. Now we have an example: chalk in water, smoke in air. We will see best example, chalk in water. Now I have water, and another one is I have, that is chalk powder. Okay, so I will add this chalk powder into this water. You can see this very well. These particles will suspend into the water, and due to this reason it is called suspension. And suspension is the heterogeneous mixture. Why we are calling it heterogeneous mixture? Reason behind it is only because of giving separation boundaries. It giving what? Separation boundaries. It is not going to be, this chalk piece powder will not dissolve into the solvent. You can see these particles are remain as it is into the solvent. It will not get dissolved. Okay, these are just dispersed into the medium, it means solvent. Okay, so it is called suspension. Now one by one we will learn about properties of suspension. First property is, it is heterogeneous mixture. Is it a heterogeneous mixture or not? Why I am calling it heterogeneous mixture? You can see it. This forms separation boundaries. This form separation boundaries. You can see it. And small dust piece of powder of piece, chalk piece of powder, that is, it is suspended into the medium, and it giving separation boundaries. You can see it. Okay, so it is our first property. Second property is, particles of suspension are visible. Particles of suspension are visible to naked eyes. You can see these particles very well. You can see these particles very well, which is suspended into the solvent by your naked eyes. Okay, there is no need to use microscope or any other instrument to further see it. Okay, the third one, size of the particle is greater than 100 nanometer. Why these particles are able to see? Reason behind it is only it having large size. It means they are greater than 100 nanometer. Most important property, that is, it is unstable mixture. Solute settle down at the bottom over a period of time. You can see it, when I added this solute, chalk piece powder, into this water, after some time it gets settled down. It gets settled down. But when we are making solution, at that time these things was not happened. Why? Solution is homogeneous mixture, and these particles are totally mixed into the solvent. Okay, we see an example, salt in water, sugar in water. Okay, but in case of chalk piece powder in water, whenever we are try to dissolve this chalk piece powder into the water, it not get dissolved, it just remain as it is into the solvent or medium. Okay, and these particles are going to be suspended into the medium, and these particles are able to visible with by our naked eyes. The reason behind it is the particle size is greater than 100 nanometer, and after some time, when time goes on, the particles from this solution, it gets settled down. It gets settled down. Fifth property, if the solution is passed through the filter paper, if the solution is passed through the filter paper, solute and solvent get separated. We will do activity for this separation. Okay. What it is saying that, it says that, fifth property says that whenever we are going to be filtration, at that time solute and solvent we will get separate. But in case of solution it not happens. So I am going to separate this mixture. This is glass rod, this is beaker, this is separating funnel stand, tripod stand, beaker and filter paper. Okay. Whenever we are doing separation, at that time the particles solute gets separated from solvent in case of suspension, but in case of solution it will not happen. It is a homogeneous mixture. Keep in your mind, when we are dealing solution, keep in your mind it is a homogeneous mixture. When you are going to learning about suspension, it is a heterogeneous mixture. Okay, it gives separation boundaries. When the particles are going to be dispersed into the solvent, it gets settled down after some time. Okay, when we are going to keep undisturbed at that time. Now the fourth property. Now the fifth property, it scattered light when light is passed through the solution, that is, it shows Tyndall effect. We know very well Tyndall effect. What is Tyndall effect? When we are going to be pass light from a medium, at that time the particles will absorb that light, scatter that light, and they get visible into the path of light. It is known as Tyndall effect. So we will see this Tyndall effect. Are you able to see these particles? These particles are going to be scattered the light and gets visible. Okay, when we are passing light from this mixture, at that time the particles are going to be scattered that light and they are going to be visible in this light. I hope that you understood this very well. Okay, my dear student. In this way, today we see suspension and its properties. In that suspension, it is a heterogeneous mixture. Along with, we will see simultaneously, we will see solution also. It will get revision again and suspension also. Okay, so suspension is heterogeneous mixture, solution is homogeneous mixture, in which the solute particle do not get dissolved in suspension, but in solution it get dissolved. Okay, and but remain suspended throughout the medium. Okay, in the suspension. Example we have for the suspension: chalk powder in water, smoke in air. Okay, for the solution it was salt in water or sugar in water. Properties of suspension: it is heterogeneous mixture, properties of solution, it is homogeneous mixture. Particle of a suspension are visible to naked eye. Okay, naked eyes. Properties of solution are not going to be visible with the naked eyes. Third size of the particles is greater than 100 nanometer. In solution, it was less than 1 nanometer. Okay, that is 10 to the power minus 9 nanometer. Okay, so now the fourth property, it is unstable mixture. Solute settle down at the bottom over a period of time. When we are keeping suspension mixture for undisturbed for some time, the solute particles gets settled down at the bottom of side. Okay, side of the bottom. But in case of solution, it not happens. It will mix completely and they will not get settled down at the bottom. If the solution is passed through the filter paper, solute and solvent get separated. When we are going to be filtration, when we are going to do separation at that time, suspension, solute and solvent get separated. See, in this filter paper we can see very well powder of chalk piece. Are you going to visible this powder? See it. And this is your solution, solvent. Okay, my dear student. And the last property, it scatters light when light is passed through the solution. That is, it shows Tyndall effect. We see. Okay. Now we see scatter light when light is passed through the solution, that it shows Tyndall effect. With the help of activity we see in this Tyndall effect. Once again I am going to show you Tyndall effect. But in case of solution does not show Tyndall effect. Okay. See, the beam of light scattered by the particles and they are going to be visible in it. Are you going to see the particles are moving? In this way, today we learn about suspension and its property. I hope that you understood solution, its property, suspension and its property. Thank you. Have a nice day. Stay home. Stay safe. Thank you.